Well, we're live. Jason, thanks so much for being with me. I really appreciate you making the time to be here. There's probably nobody in the game of golf who knows more about golf shafts, the theory behind it, and then also all of your experience on how to make it work the best for the golfer, for the long driver, since this is the Pro Long Drive podcast. So thanks so much for being here.
Pleasure. Thanks for having me, Steve. Anything for the PLDA, I applaud the effort, and hats off to everybody involved, Bobby and Ryan and the whole team, yourself, and all the flag bearers, like these star athletes. It's a perfect storm for PLDA. Came at the birth was the right time and the wrong time at the same time. So I'm here. I'm happy to be here, and I'm really impressed with you guys. Always have been.
Well, great. Thank you. I've had the pleasure of hitting your shafts, Kinetixx shafts, for a few years now, and there's no turning back for me. So let's start with long drive, and we'll get into some other topics as well. But
sure,
Kinetixx has really kind of taken over and dominated the world of long drive. Most of the top guys in long drive do play Kinetixx shafts. You've got multiple world championships. You had the really cool scenario in 2019 where Kyle and Chloe both won the world championship in their respective divisions using the same shaft. That's got to be pretty cool from your perspective, huh?
I appreciate you. Thank you. Thanks for bringing that up as well, because it is very unique and there's no fluke to that. And I lost my thick head of hair getting to that part of the journey, but yeah, it was fruition the way it should be, and we're really proud of that. So we love long drive. So there's no fluke that we ended up in long drive. We kind of got laughed off and on the PGA Tour in the beginning when we launched, and so I had to demonstrate to the best players in the world that the most elite athletes, the fastest players in the world, the long drive athletes, male and female, could actually benefit from the same technology that these guys were, Aristotelian thinking we weren't the right spec. We had set 6 course records on the PGA Tour and still weren't appreciated, I guess, in that regard, just because it was disruption. Science is always hostile to innovation, but the PGA Tour, and you get these pariah type of reps out there, it gets pretty cantankerous. So yeah, we're really proud of that. Proud of Kyle, proud of Chloe, and all the other athletes like yourself and everyone else, who've embraced what we have to offer, because we put more into our product technology than any other shaft brand. That's a fact. It's just simple as that. And we're proud of that. The other thing I'll say is, other than we're only one of 2 shaft companies that actually make raw materials. We have a pretty strong raw materials business. We're much smaller than our competitor in the space, but so we speak from authority. And so what we present is incomparably the greatest technical value proposition there is in the industry. And if I can benefit you and the likes of if we can deliver a technology, product technology that benefits players like yourself, athletes like yourself, it benefits the average golfer all the more. So
I can imagine it is disruptive to have someone come in and take a very different approach to it. But you do such a good job of backing it up with your knowledge, with testing, with everything like that. So give us a little, kind of brief background on your education, your background. How did you get started in shaft design?
Yep. So myself and my whole team, we're skilled in the art. So physics and materials and mechanical engineering. So it's a confluence of all. And so we don't do anything that violates the laws of physics. And generally that's supported by the math and then the theory, right? You have two parts to that equation. And over the years, we've evolved in developing technologies for others that have actually benefited what we have today in our own branded products. And we're always a deliverer of, performance value proposition, not contracted manufacturing, even though we have a very tiny segment of our business that does that. So it's always technical value proposition. How much more can you show me in terms of performance, whether it be spin, whether it be distance, whether it be dispersion, and And so, yeah, and I have a strong physics and math background as well as materials, and I love electrochemistry, and I think it's the most noble of all the subject matter, and it benefits us and our processes for manufacture. And so over time, we started putting to practice methods of manufacture that would allow us to separate ourselves. So it's not just simply buying something that can make or a process, run a process from one particular way. It's learning how to use it and learning the benefits of what you can do in terms of grabbing and pooling materials that otherwise wouldn't be successful. So what you see in our product is really, again, it's a confluence. So it's a confluence of materials and craftsmanship, and that's with on the basis of our knowledge and expertise. I'd like to think spearheaded by from myself and my team. So it shows up.
That's one of the things that stood out to me. I mean, I initially just tried the shaft. Bobby Peterson, I believe, was the first one to have me try a Kinetixx shaft. And so I didn't know anything about it. But then as I learned more, and I learned you've got your own production facility, which is something that, like you said, there's not many of that. That puts you in very rare category right away. But then you also do things so differently. Let me just jump back a second though. How did you take that background and decide to get into golf? Because you could have gone a lot of ways.
Some ways I wished I'd gone other ways.
Excuse me for a second. I want to tell you real quick about my favorite training aid and a sponsor of the podcast, the Lag Shot. It's designed with what they call lag flex technology that'll help you to create and maintain more lag in your swing, which will give you better consistency and more speed, which we all want, right? But my favorite part is that you can go out and actually hit balls with it. It's a real club. They make a driver, a 7-iron, and a wedge. So you can incorporate it into your practice sessions to ingrain the better technique that it's teaching you. Once you try it, you'll see why I love it. Go to lagshotgolf.com/crush or click the link in the description below to get 15% off. lagshotgolf.com/crush.
But the reality is that I'm a athlete and golfer by spirit and passion, and hockey, skiing. So I like the winter. I grew up in Canada, so you can relate to the cold weather, I think, a little bit. Not now, perhaps, but I know you're from the Midwest. So the reality is, if it's not frozen, we're going to be walking on it. And if we're not skating or skiing on it, then we're going to be walking on it. So, passionate and sporting enthusiast is what I am. And with a technical background. And so ultimately I actually came up with a couple of inventions, accessory products in the golf industry, as well as a actual computer generated program for basicly tee times, and then got into the next level, which was putting to practice some of the ideas I had for golf technology within the constraints and confines of the USGA and RNA back in an early age, when I was just a high school kid, prior to college. And so ultimately, I had a few inventions over time that evolved through school that I wanted to put to practice. And I met my partner in Patterson today, my Kinetixx technology. So we are Kinetixx Technology. Our global entity is Kinetixx Technology. And Patterson was formed by my partner. Originally, it was 4 years prior to me coming on board with him. And we decided to conspire and formed our entity that is today. And actually, we had another individual that was part of our group that we joined part of his group, who is no longer with us since he passed away, and it was the clubhead side. But collectively, started building up a book of inventions and art, and selling it to the industry. And so we come full circle to today, and we're a vertical corporation, vertically integrated product technologies, from materials to multiple sports to components and parts in footwear and bicycles and a number of different little things that we dabble in. And, no is not in the equation, provided it doesn't violate the laws of physics, I guess. And so, it's neat how momentum builds. You have an invention and you put something to practice, and perhaps it doesn't turn out the way you want it to. And ultimately it births another idea or invention, and that one might turn out well. And that's kind of what happened for us and for me. And so almost 30 years in the industry. And we've done all kinds of products, pridefully and some regrettably.
Well, I'm very glad that you chose to get into the game of golf. As I said, I play the Shabs and love them. As far as what makes them different, I'm sure we could take a really deep dive here and get into all kinds of, technical specifications. So maybe we can get some of that. But the way I understand it, you guys make your shafts differently than just about anybody else. Instead of, and again, you could explain this way better than I could, but like a traditional wrap or, kind of wrapped shaft where it's basically a sheet that's kind of put together, you actually interweave the fibers. Is that right?
So that's one method. So actually, there are uniform methods of manufacture that we've actually taken to another level. So I guess that's the best way to put it. So that differentiates us. So you can filament wind a shaft. You could laminate a shaft. So it's layer by layer, flag layer by layer, and wrap it. And then you can put it into a mold, what's called the resin transfer molded process. So you form the shaft either with a bladder or an insert of some kind, and you form the shaft around a core, whether it be air through a bladder molded process or transfer molded, and then or wind it. But what we've done in our specialties are filament winding and laminate construction. But what we've done in those segments is continued the art to the form of doing it in a way that no one else can or does. And that's what makes us unique. So we filament wind. That's the interwoven part that you're talking about. So those are truly geometrically spineless golf shafts. And nobody else on the planet can make that claim the way we're doing it.
I have a prop to showcase that.
Our ballistic TP. There you go.
So you can actually see the actual filaments fibers in there.
Visible fiber structural technology. And that is a net part. We're the only shaft company on the planet that does this. That is a net part that comes, that doesn't go through a centerless grinder. And there's several companies that made the claim for spineless, and now there's a couple wannabe guys, dumpster diving around the industry, making some horrible, egregious claims, and some fitters that are getting behind that. Unfortunately, it's just that actually now starting to disconcert us and myself particularly, and I think the consumer's getting hoodwinked by some, and in this case they're not. I mean, it's indisputable what we do, and so what you see there, that's the use of Kevlar. We're using Kevlar for its elastic strength because we're able to actually tension it. No one does that. We preload our fiber.
Yeah. Talk about the pre-tensioning if you can.
Yeah. So it's very unique. We're able to actually tension our fiber, and we can do it in a laminate construction too because we vacuum cure. So what we do is we're able to actually minimize the resin content and maximize the fiber area weight because of our curing method. No other company in the world uses a vacuum curing system. They static autoclave, yes, but not vacuum curing. Big difference. It allows us to use the same resin systems that, say, the SpaceX Dragon capsule uses, and really unique and very, very noble chemistries for resin. But it also allows us to flow resin through the shaft, suck it through the shaft, pull it out, get the fiber coverage we need. So when we can put the fibers under tension, then we can preordain the shaft for a particular result. And so whether it be filament winding through tensioning in our winding process and or our laminate constructions, the same way, we're able to actually preload the fiber. And it's very unique. So it preordains a shaft for performance result. And for example, the buzz in golf industry right now is soft shafts. Actually, our velocity shaft in the long drive segment is anything but a soft shaft. All of our product is tailored to get to increase in frequency, the greater the force applied. In other words, that shaft actually may appear soft, and under the premise of how today's products are audited through CPM, frequency analysis, that's actually not a science. It's just a characterization scheme for actually determining what range a product is in a flex under a very limited test parameter. It's great. We all use it in a sense to a certain degree, but it's very limited to a higher order of a magnitude. And that's where we thrive, is in that higher order of magnitude. So we might present a product that some of the guys are, built drivers at 235 CPM, whatever, to the average person, they don't understand what that is. But at the end of the day, the actual frequency of that shaft is not, that's what is on the basis of just a simple CPM measure. So it gets very stiff. That's why we have a very low failure rate. And while at the same time, we actually are allowed to tailor the product to allow the club head to do its job. And so from that perspective, that ability to make gives us that freedom using materials. We're using Kevlar in that shaft you just showed me. We're using an amorphous nanocarbon in the Velocity series, which has come a long way, by the way, and where it is today. And and again, that's the product of how we make. So vacuum curing with all of our products, filament winding, and preloaded laminate construction as well.
It's very interesting stuff. I remember back, I used to be more into cars than I am now. And they had, like a carbon fiber hood. It looks like a really cool thing, reduces weight, stuff like that. And then if you didn't want to buy that, but you wanted to have that look, they would have like a cover that looks like it's carbon fiber and it's not. So for everybody who maybe didn't pick up some of the details of what you just said, Kinetixx actually does like the real thing. It's not that you're putting a sticker on it and making it look like the fibers. It actually is showing the fibers in the construction itself. Like, so that's the real deal right there.
Thank you.
Really cool.
And from that perspective too, I'll elaborate one step further. I've seen now in several other of our competitors' products, I can show you and show anybody in the world where their transgressions are in terms of their story to reality. And I mean, you can't pull the wool over my eyes, at least. They're not as good as they used to be, but at the same time, with my glasses on, I can tell you and show you everything. But again, yes, it's more of a sizzle than the steak part of it, and if you will. So yeah, we're really proud of that. That's why you'll see tiny little imperfections even in our let's say our wound Kevlar series there that you're showing me there. That's just natural. Fibers splay but it is, exactly as it appears. You
brought up a really cool point as far as measuring the shaft with the CPM, because here I also have one of the more flexible ones of CPM, but there are different ways to measure it. And so, like you said, it becomes really stiff under more force, right? So I hadn't considered that, though, right before you mentioned it, that the CPM is only like one component of the profile of the shaft. That doesn't determine its actual flex.
No, that's correct, because that test is limited by the condition of the test, right? And as you mentioned, your math background, you'll understand this. So on the basis of you've got a limited portable test. So it was developed by an individual in the industry who needed to characterize sort of in the field where the rubber meets the road what that relates to for the average guy, clubsmith, if you will, a clubsmith, like guys who are assembling clubs, no different than today's the quote builder quote. They're assemblers of golf clubs, and a little higher order than just basic, cut and glue, but at the same time they're just assembling product that they've received. So there's some Aristotelian and esoterica, and then there's some reality. But the baseline for them is to use CPM. So we do too a little bit at the end after our product is finished, just so we can actually then speak to the average person. Yeah. We're not trying to recreate the wheel. We're just trying to improve the performance.
Yeah, you can't send a paragraph to a customer who asks what flex it is. So you've got to come up with some metric that at least is convertible to that sense.
Exactly. And it works very nice. I mean, no different than the way CT testing is a very basic portable test independent of the golf ball. But at the same time, it is just that. If you really want numbers, you need to do a full coefficient of restitution test. Mm-hmm. And so from that perspective, yeah, we do a neutral plane alignment and a natural, not a natural bend point analysis or audit, which would be like more in the CPM thing. These guys are talking about flowing, and that's more in natural bend point analysis versus neutral plane alignment, where we're actually tensioning the fiber under a much higher order magnitude, and we're measuring compression and tension on the walls of a shaft. And because a shaft is tapered, there's going to be some polar aspect to that. So, you might characterize a pole or a very tiny peak that allows you to, preordain the shaft, whether it be through painting and placement of logo. You're preordaining it for, if you're really doing your job right, the neutral plane alignment versus natural bend point. There's a big difference, right? And so from that perspective, we do the engineering so that everyone else can do what they do best. So that's our job. It sounds like it. And that's the goal.
It sure sounds like it. Stuff like that, even logo placement, painting to affect all of that, that's something that most people would not consider, but it really plays a huge role in the performance. And especially when you're looking at, higher level performance. So whether you're a tournament golfer who wants that kind of like perfect consistency every time, or if you're in long drive where you're pushing the limits of what certain equipment and stuff can handle, and really how far people can possibly hit a golf ball, that attention to detail and that very thorough consideration of factors that just other people might not consider makes the difference. People are always looking for an extra yard, an extra percent. Well, right there, you just mentioned multiple percentages. Let me bring up one kind of side issue. This is my last prop for the day, but
sure.
As you know, this is the charged version, which looks amazing. Hopefully people can see on there.
That's great. I'm glad you got that. Yeah, that's great.
So what's the idea behind that charged? I mean, is that just another component of those pre-tension fibers that then you're maybe adding like polarization to it?
Actually, we just forwarded a utility patent on that as well. Wow. And so we're proud of all of our IP. But the reality is, that is a high-speed steel alloy that you're seeing. That's steel wire embedded in the shaft. And actually, we have a commercial product. So that's your world's only true embedded swing weight system, if you will, balance point system, however you want to look at that. I mean, in essence, balance of the shaft will determine swing weight. I use the word swing weight because a lot of golfers relate to that. Yep. But the reality is it may not be the correct way to build a product, but it allows us to inertially tailor a product. So that's actually a laminate construction. It's preloaded, same way that the Velocity would be, and it's vacuum cured. But we're also using, which is our own internal, we're a fiber maker, so that's actually pre-impregnated sheet, alloy sheet. So it's unique in that regard. It's high-speed steel, so high density, high ductility, high ductile strength. So it's very unique in that it's a grid. And we're using it for balance as well as stiffness. So we're actually able to tailor the balance point and the stiffness characteristic of that product around that location, and that also is very unique. On that note, when talking about stiffness and balance point, say kick point, if we go for shaft speak, we're able actually to delineate them too at times based on our processes. So we don't necessarily have to have the balance point be on top of the kick point, if you will. And a lot of times you'll see that with all the other products out there in the market, they're very limited to running down one path. Now that's good from their own perspective. And today's average, premium products do their job by trying to constrain the shaft, but we have elastically tailored composites. So we're actually allowed to afforded the luxury, having 3 degrees of freedom in our processes, we're afforded the luxury of tailoring the elastic response to stiffening effect that would allow the club head to be independent of the shaft at the moment of impact. No matter what we're doing, or we can couple our shaft to the club head. For example, we're the only zero torque putter shaft out there. We have a conventional one with requiring a grip as well as gripless technology, but more than that is truly the only zero torque product out there. And we don't have to make an egregiously thick tip. So everybody makes up for their shortfalls by overcompensating with layers. We're not like that. Actually, we're very, very noble in that way. And that's our use of material maximization, if you will.
Yeah.
So again, with everything we do, we take the whole club into consideration, and we know the whole club better than any shaft company does. That's fact. We're the only shaft company that actually makes club heads as well. It is part of an OEM business. So
how hands-on are you with coming up with these ideas? Are you testing and saying, oh, well, what if we use Kevlar or we use a steel alloy? What role do you play currently in that process?
I'm the, I guess, if you will, I'm the catalyst for our push, and it's probably to my board and partners at times dismay, but I don't rest. And so I more often than not will be the guy that says, okay, I want to do this, we need to do that, and this is how we do it. And so I'll lay it out, map it out, and then I'm actively engaged throughout every step of the way, whether it be CAD or transient analysis, or right through to the production line and just evaluating and truly proof of concept testing. So again, unlike most shaft companies, we're actually very equipped, and so we do a lot of performance testing in-house. Been very proprietary at this point, but it's no secret. I mean, we're the only shaft company to this point from our inception. It's our fourth robot, but we've used hand, wrist, and arm, whereas even True Temper used iron Byron. I'll just say that it was a casting mechanism, so it never incorporated wrist, which is really good for club profiling if you're mapping club face impacts. But if you have no wrist and you're just reliant on elbow, cock and bend, then you're going to limit, your developmental process when you're building, when you're developing shafts that have to take into account butt to tip reaction.
Yeah. So in many ways, and I hope you don't mind this analogy, but you're kind of like the Elon Musk in the golf world, the golf shaft world. You're innovating things that are totally different than what have been done before, and you're bringing this really intricate and creative process in a really cool way, and the results are showing. So congrats, and I hope you don't mind that.
I love that analogy. And we're the only green company in golf too. Our whole manufacturing operation is 85% solar driven.
Wow, that's great.
Green. Yeah.
Yeah. I know you got to run in a minute here. Let me ask you two quick questions. So, well, they're not going to turn into quick questions, but maybe. So first, for someone like me or another long driver who wants to also use Kinetixx shafts in the irons, what are good options, and where can we go about trying those?
So our ballistic iron series is the next generation. It's neither steel nor graphite. It's use of Kevlar, and at the end of the day, we are the only shaft company that makes every shaft of discrete length. And that doesn't, whether it be putter shaft to irons, each and every iron length is its own mandrel, which means that we've had to take into account and engineer a mandrel for each and every shaft we have. So why is that important? Because if you look at a club head and its aspect ratio and the geometric tensor values, they change as the club lie and loft change, and as the package design changes and the weight changes. And so it's not simple, put a stick in the hole and glue it and go hit it and expect the result. So our objective is to tailor flight and distance in an iron system. So we have a variable set of irons that incorporate our 3 degrees of freedom in our manufacturing process, pretensioning. We take into the winding pattern changes throughout the set, all the elements and parameters of balance and kick and inertia. Those change throughout the set as we deem fit relative to the obliqueness of the impact. So it changes through your bag, whether you're dealing with a high lofted wedge or a low lofted, 3-iron. And those parameters, what you demand as a golfer for whether you're a 36 handicap or a professional on the PGA Tour, those requirements per iron change. So if your iron head changes, wouldn't it make sense that your shaft moves along with that, because it's supporting that structure and that system? So why our iron shafts are so superior is that they are tailored for each impact relative to the club head form factor and the parameters of most conventional clubs for each particular loft, or if you will, because there is no such thing as an iron anymore that's an iron, because you have companies that are producing 5 irons that are yesterday's 3 irons and vice versa. So from that perspective, and I'm not knocking that, because some of them have gotten it really right because they were able to locate center of gravity. That speaks to club head manufacturing in a sense where we're able to do more in club head manufacturing than we've ever been able to do. So you can actually have a quote hot lofted club, but get the trajectories of desire. And we're able to preordain our shafts for the same effect around that system. So some of our heaviest weighted irons, again, they're geometrically spineless, so they don't oval, they don't pulse, they don't deform the same way. A lot of players feel they play very stout. Most players have to weight down, flex down, or both as a demonstration to that in our iron shafts, because they're used to playing product. Let's say it's 110 gram or 120 gram. Player like yourself, 120 and 130 gram iron, but it pulses and it ovals, so it loses energy. Whereas our 110 gram iron will be more robust than that 130 gram iron that you're applying in a steel shaft. And it's a much more tailored, it's a very ready composite. It's preordained for that type of impact, and it'll be there for you on the basis of what you're putting into it, and in terms of energy. So we're going to maximize your potential energy, whether it's you as a great player, and I know you are, or the average golfer who needs that help on the lighter side. And so yeah, that's a uniqueness to what we do in that regard, for sure.
Yeah, it is. You touched on a bunch of things that I wanted to get to, so maybe we'll have to get to those next time. Swing weight, kick points, because maybe that's another metric that is just a way to talk to people, but it doesn't necessarily carry over the same way. How they can carry over, how your shafts can carry over to average golfers and slower golfers, and a lot of stuff I want to get to. So we'll have to do that next time. One last thing that I just want to know if you've considered it before. I've hit against other long drivers in testing and other tournament golfers as well, where maybe one person will swing faster. And let's say that person hits a good one and a slower player hits a good one. So launch and spin and stuff are all roughly the same for this experiment. But one person hits it further and faster. And my thought was, I know it's not going to be as simple as like F equals MA and whatever, but maybe somehow the slower player is increasing their effective mass at impact. Have you thought of anything like that before? And again, because the whole body's part of the whole equation now. So it is a gestalt there. There's a whole theory concept behind that, especially when you look at the biomechanics of the golf swing and how that plays into, we're all potential, and we're bundles of properties, right? As human beings, your golf clubs are bundles of properties. They're solid matter. We're soft matter. And you couple these two systems together. So you have potential energy in the human element, and then you have potential energy in your static equipment. And believe it or not, it sounds esoteric. It's anything but. It's truly what we're all looking at on an R&D perspective every day. If you're studying physics of impact and the biomechanics of the golf swing, because those two there's a confluence there between those as well. And a lot of times what it really boils down to, Steve, is efficiency. And that person's really well tailored for their gear, and it just happens to be a really good match. And so they get higher efficiency ratios than those who maybe have a menacing appearance and put up great numbers, but aren't getting that efficiency. You don't look at some of
let's use golfer speak, some of the smaller stature tour players over the years who had enormously heavy hits. And I know Bobby speaks of some guys, oh, a heavy hitter. Well, I know he's using that on a field basis, but it's actually truthful because you look at guys like an Anthony Kim, days of old, small guy. And man, he made the ground shake. Very well tailored. And, even a guy like a David Duval, he was at times he was heavier than others and very svelte at one time and still made that ground shake. So again, these are great biometrically, if you will, tailored, systems, the people and to equipment that worked for them at that time. Yeah. And there's some long drive athletes, same way, who are doing that and breaking the boundaries of performance as a result. And so, yeah. And the further we delve into this and the more freedom we get, and the more our materials evolve, the better we'll optimize that, if you will. So the greater our output will be. We're pushing it now. And
it'll be interesting. It'll be interesting to see how, as things keep developing with AI and whatnot, when the USGA might when you can cross some of the lines of what would be a conforming or a non-conforming club. I'm sure that'll be pretty cool.
They're already frightened, because I will say this: I've got a couple inventions that are patented, utility patented, and the USGA was harassing us back in the day of actually filing CIPs and divs, which was outrageous. It was egregious. In fact, we had to get a restraining order against one technical director from the USGA, and he was so out of place it wasn't even funny. But the reality is, we presented them with and the only golf club on the planet today that has a computer chip in it. We take mechanical energy and create electrical energy, and then a mechanical response, all within the impact event. It has a CT, if you will, characteristic time. That's the buzz here. Let's say coefficient of restitution, let's say 82%. So it's well below the parameters of, it loaded, it was say 245 CT. And it produced at 100 miles an hour. It produces, to this day, it's a very live product. It may be commercially exploited soon. It produces carry distance over 300 yards. Wow. And 100 mile an hour swing speed. So, and it meets every other boundary. It's the same volume as anything compliant. It's all within the parameters. So if you looked at it, you wouldn't think anything else. So the USGA is very nervous about guys like myself and others, some of our peers and perhaps competitors. But the reality is, give me if they think the issue is with the ball, they're so wrong.
I can see concern with, if you then put that in the hands of like one guy in a tournament versus another guy not having it. But for the recreational golfer, that is so good for the game of golf, because everybody wants more distance. And if people can get out there and can hit it 300 yards with a 100 mile an hour swing, they're going to enjoy it so much more.
Well, think about how that guy feels, or gal. They go out and they play a big golf course that they paid huge money for and can't clear a bunker or a water. Like some of these PI golf courses, they have zero forgiveness when it comes to, you either hit it in the lake or you hit a stake in one of the railroad ties. It's demoralizing, and they've got huge dollar invested in that day. They feel horrible after they've gotten off the course. They need a drink or whatever, a libation of some kind to change their perspective. That's not fun. And I don't think golf's going to give somebody some illness, God forbid. But the reality is they're governing it like it could. Yeah. And that's wrong. I agree. There should be bifurcation at this point if they feel it needs it. Although the commercial game would benefit as well. I think it's hard the genie's out of the bottle, so it's tough to. Yeah.
That's true. That's very true. Well, I really can't recommend to people strongly enough. Try a Kinetixx shaft for irons, putter. I haven't been able to try the putter one very much, but and certainly driver as well. So
Jason, putter is off the charts, and we'll get you one. The reality is it will harmonize the impact event. In that case, just real quick, it is it's coupled to the head, because the ball dwell time is longer in a putter. There is nothing more stable in a putter than our tuned zero torque putter shaft, and that'll be available, and you'll see it more clearly on our website sooner than later. We have a new website coming probably by July.
Yeah. So where can people find you? Website and social media?
website, social media, and some of the finer fitters in the world. But go to our website first for direction or direct order.
Will do. Awesome. Jason, I think we're about to get kicked out. Thanks so much for your time. I really appreciate it.